So this is lesson 7 in our atomic structure unit. Notice our title, How the Energy Released from Electron Transitions Produce, this actually doesn't make sense, when passed through a prism, produce spectral lines. Well, let's talk about this. Recall we said that electrons make transitions, and we're going to only consider one direction right now. We're going to consider the transition that happens when an electron in an excited state falls to a lower energy level, perhaps the ground state. I'm going to talk about 3 transitions, one from the 3rd to the 2nd energy level, another from the 4th energy level to the 2nd energy level, and the final from the 5th energy level down to the 2nd energy level. Now, notice that I have, the first transition that I drew here is the smallest distance, and therefore it represents the least energy. Now, if I happen to have a prism, actually I have to have something else. I have to allow this light to pass through a thin slit. And then if I have a prism, or actually in reverse, if I pass it through a prism, here's our prism right here, and then I pass this light through a thin slit, it'll produce something called a spectral line. Let's go to, let's see if I can use my colors. So as I said, this first transition here is going to release light energy. And so we're going to have this light traveling out like this. And then on Earth it encounters this prism. And it's going to scatter that particular light, and it's going to separate it, and it's going to produce a red line, because that strictly is producing, let's say, light of 650 nanometers of wavelength, which is perceived by the human eye as red light. Let's say that the second transition here has more energy, and it's also going to give a photon of light, and the prism is going to scatter that packet of energy a little bit more, and that's going to be perceived, that's going to produce a green line. The final one is the biggest change in energy, and therefore it's going to produce light of the greatest energy. Turns out that blue light is one of the most energetic of the lights, and that's going to be scattered more. Blue light is scattered the most of these, and that's going to produce what we call a blue spectral line. So each of these is called a spectral line, and what we say is that if this is all of the possible transitions that electrons make for this element, then we would consider this to be what we call the bright line spectra for this element. In other words, you can use this bright line spectrum to identify the element. So in other words, if this is an unknown, what you can do to that unknown sample is you can heat it up. If it heats up, it can give off light. You can pass that light through a prism, through what we call a diffraction grating, and it will produce this characteristic bright line spectrum. So you really can think of this as being, I guess, the light fingerprint for this particular element. Meaning it doesn't matter in what kind of sample you find this. This particular element, if present, and if it gives off light and that light is viewed through a diffraction grating, it must produce this characteristic bright line spectrum, which can be used to identify the element. It's a very handy little trick. There's something else we can do, building upon this, about this fact of elements. Let's read this. When elements X, Y, and Z are vaporized and their electrons are excited, the following spectra are produced. So let's just say we're dealing with 1, 2, 3 different elements. We'll keep it relatively simple. Let's say that X, the bright line spectra of X, are 2 red lines, like so, around 650 nanometers. Let's say that element Y has, I'll use my limited palette here of colors. It produces 1 green line and 2 blue lines, like so. Element Y is identifiable because that is the bright line spectrum it produces. Finally, Z only has one kind of color, but it's going to, let's say, produce, that'll be confusing. Let's do it like this. It'll have one red line like this and one green line like this. This green is slightly different than that green. This red is slightly more orange than those reds. Now, what's interesting is that if I had a compound consisting of these three elements, and I vaporize this compound and I analyze its luminous emanations, the kind of light it gave off, it would produce a pattern that is the sum of the spectral patterns of its three constituent elements. So, if this compound contains X, it's going to produce X's two red lines. If it contains Y, which it does, it's going to produce Y's, one green line, and two blue lines. And then finally, if it contains Z, which it does, it's going to produce that specific red line of Z and its specific green line. So very interestingly, by looking at, I can identify a compound by comparing the spectral pattern of that compound to, let's say, a library of spectral patterns. And just by comparison, I can see that clearly, these two red lines are in the sample, which means that Z is part of it. And then I can look and say, I can see that this green line and these two blue lines come from element Y, so Y must be part of it. And the remaining two lines, the red line and the green line from element Z, are also there, which are evidence for the presence of that one as well. So again, a very powerful little tool that's used all the time in, for example, forensics, in order to identify samples or to identify specific important compounds in samples, let's say, from crime scenes. Okay. So with that said, that is all I really need to say about this particular important subtopic, this particular application of spectral lines. Let me just emphasize that, again, when we ask you how light is produced, that can also be asked how color is produced. That is also asking how a spectral line might be produced. No matter if I talk about light or color or a specific spectral line, this all is rooted to an electron transition. When an electron makes a transition from an excited state to a ground state, energy will be released as light. That light will have a specific color. And if that color is passed through a prism and then through a particular small passageway, it will be perceived as a spectral line. Thank you so much, and that was all for lesson number 7.